Hi guys, welcome to this session. We're going to have a look today at atomic structure and electron structure. So we're going to look at the fundamentals, the basics of chemistry that everything builds upon. Okay, so here we've got a structure of an atom, and very typically exam questions ask us to identify the names of the particles, their mass and their charge. So this is just a piece of knowledge that I would say learn. Make sure that you can fill in that table, and we'll see in a little while a typical question where there is parts of the information in there and you to fill in the remaining. Okay, so the three subatomic particles that we have a proton. A proton has a mass of 1 and its charge is positive. That works quite well, positive proton. Okay, whether you write the word positive or you put a plus sign, either is acceptable as an answer. We've got our protons, we have our neutrons that also have a mass of 1. Neutrons are neutral. Be careful, that usually trips people up because they go positive proton, negative, which is neutral neutron, and therefore if we can lock those two in, our final subatomic particle is our electron. This has a mass that is so small we can simply put 0. Sometimes you'll see it as 1/1840. Okay, if that's locked in your memory, that is fine, but we can simply just put 0 and you will get the mark, and it has a negative charge. So a couple of things then about atoms. When we look on the periodic table at the symbols, these two numbers can tell us everything we need to know about the number of protons, neutrons and electrons. So if I just copy this table, and we can take this with us to the next slide. So we've got that as reference. I'll just make it a little bit smaller, push that up there out of the way. Okay, so remember that you get your periodic table in an exam. Okay, so when you look at your periodic table, there is a key on there, and that will tell you that the top number is the mass number, and the lower number is the atomic, and it has in brackets proton number. Okay, so by using these two numbers we can work out how many protons, neutrons and electrons each element has. So if we start with a mass number, if we look back in our little table, we can see that the two subatomic particles that have mass are the protons and the neutrons. So the mass number is the number of protons plus the neutrons added together. Okay. The bottom number, the clue is there. It tells us that this is the atomic or the proton number. So this tells us how many protons a particular element has. And as we know that atoms have no overall charge, this is because they have the same number of electrons as they do protons. If you just cast your eyes back up to our little table, protons are positively charged, therefore we need the same number of electrons that are negatively charged so that that atom has no overall charge. Okay, so in terms of working these out then, let's work it through. Easiest one is to start with the protons because we're just looking at the proton number, so it has 6 protons. That must mean that it has 6 electrons. And then our mass number we can use to figure out our neutrons, because now if we know that we've got 6 protons plus something equals our mass number of 12. So therefore we must also have 6 neutrons. Now don't let that fool you, it's not always the same. There are lots of examples where they do have the same number of protons, neutrons and electrons, but it's not always the case. If I very quickly just show you lithium, for example. So lithium's mass number is 7, its proton number is 3, therefore it has 3 protons, has the same number of electrons. However, the neutrons, we've got 7 minus the 3, so it has 4 neutrons. So sometimes they do differ. Okay. Now, just a quick recap, thinking about these subatomic particles. The number of protons dictates what element it is. So when you look at a periodic table, if you look at that bottom number, that just increases by 1 each time. If we change the number of protons, we would change the type of element that we have. Number of protons is always equal to the number of electrons because atoms have no overall charge. If we start changing the number of electrons, that's when we start talking about ions, because an ion is a charged particle. Okay, so we know how to work these out. So sometimes we see a variation. So let's look at these two for example. So you might have heard of isotopes. Let's work out what isotopes are by doing exactly the same process. We're going to work out the number of protons, neutrons and electrons, and I'm going to refer to these as carbon-12 and carbon-13 so you know which one I'm talking about. So carbon-12 is just what we've been looking at. Protons, bottom number is 6. Electrons, bottom have to have the same number of electrons as protons, so therefore we've got 6, and the neutrons we've just worked out again is 6. However, when we look at carbon-13, proton number, bottom number is 6. Electrons, we haven't got any charge, so we presuming we've got 6 electrons. However, this time we've got 13 minus the 6, which gives us 7 neutrons. So isotopes are defined as atoms of the same element. They have the same number of protons. Remember, that is key, because if we change the number of protons, we change the element. So the same number of protons, but a different number of neutrons. And questions often ask you for a similarity and a difference between isotopes. Okay, so their similarity is they have the same number of protons, different neutrons. Okay, so the only thing that changes in isotopes is their mass. They look exactly the same, they will react the same, they would taste, smell, everything else would be exactly the same. The only difference is the mass of the element, because we've got an extra neutron or possibly an extra 2 neutrons, and we know that neutrons have a mass of 1. Okay, let's take a quick look at electron configuration then. So configuration is just a fancy word for saying how things are put together. So how are those electrons arranged in those atoms? So let's stick with our carbon. Okay, so carbon is 6, proton number of 12, and we know, because we know now, that the number of protons equals the electrons, so we know straight away that carbon has 6 electrons. Okay, so a quick recap of our rules then. The inside shell fills first. Okay, because that is the shell that is closest to the nucleus. And inside the nucleus we have our protons and our neutrons. So inside the nucleus is where we have our positive charge. So the positive charge will pull those electrons towards it. So that inner shell is going to fill first. And in terms of filling our shells, the first shell, so the one that is closest to the nucleus, can hold 2 electrons. Sorry, I've just lost where my pen is. So we can have 2 in the first shell, 8 in the second, 8 in the third, and 2 in the fourth if we need it. So popping back to our carbon, we're going to put 2 electrons in that first shell. Once we have those 2, we have to move out to the next shell. Carbon has got 6, we've placed 2 in, and therefore we must need 4 electrons in the second shell. And if we'd got to 8 in that shell, we would simply then move out into the next shell. Okay, so if you're asked to draw the electron structure, take a look at the proton number. Protons equals electrons, and therefore you can work out how many to put in each shell. 2 in the first, up to 8 in the second, 8 in the third, and then if we need it, we can have 2 in that fourth shell. Okay, so let's have a look at some questions then. So how is this going to be put to you in an exam? So lots of questions. These are what I call a leading question. So a question, it might actually be about bonding, but it will test do you know the structure of an atom first. Because if we are talking about ionic bonding, for example, we need to understand that when we lose an electron, or when we gain an electron, that overall charge will change because our electrons are negatively charged. If we lose one, we're going to have more protons, so we become positive charged. But that we'll cover in another session. Okay, so here we've got excuse me, a magnesium atom. Use the words from the box to answer these questions. Now be careful, when we've got a question like this that says use the words from the box, please use the words from the box. Don't make up your own words. They're there to help you. Okay, so the first one, what is the name of the central part of the atom? So the protons and the neutrons collectively are in the nucleus. The name of the particle with no charge, so it is neutral, is a neutron. And the particle with a negative charge is the electron. Okay, so this would be to test your atomic structure, and then it would lead on into the remainder of the question. Okay, a higher level question around atomic structure is something like this. So it's asking, the question is about atoms and isotopes. The question leads on to isotopes later, but as I said, what we've got here is we've got the leading question that is testing your knowledge of atomic structure first. Okay, so here we said that a lithium atom, and it's giving you the symbol, mass number of 7, proton number of 3, and explain in terms of subatomic particles why the mass number is 7. So we have to think about what particles are making that mass, and why do we have 7, because it asks us to explain. So why has it given 7? Okay, so 3 marks available. So things we want to say is that lithium contains, so remember the 2 that have mass are protons and neutrons, contains 3 protons and 4 neutrons. Okay, so there I've hit 2 marks. Because I've identified, I've used my knowledge, I know I can work out that it's got 3 protons, 4 neutrons. And my 3rd mark is for then just basically identifying that those added together give the mass of 7. Okay, so here we go. Here's our little table that I said just learn it, just get that information locked into that long-term memory, so that if you get a little question like this as your leading question, it's 2 marks in the bag. So a neutron, relative mass, the mass of a neutron is 1. The charge, remember, a neutron is neutral, so we have 0 charge. In the second line, we're given that the charge is positive 1. Positive is our proton. And our proton again has a mass of 1. Now there are 2 marks available. You get a mark for each correct row. So if you have correctly filled in the line of neutron that it is 1 and 0, that's mark 1. And for the second line, it's proton and mass number 1. Complete the diagram to show the electronic structure of magnesium. Again, this question might then lead into some form of bonding question, but it wants to know, can you identify how many electrons it's got, and can you draw the structure? So when we look at our periodic table, magnesium is 24 and a proton number of 12. It's got 12 protons, it must have 12 electrons. 2 in the first shell, move into my second shell, and I can place 8 in the second shell. That gives me a total of 10 so far, and then 2 in my final shell. Doesn't matter whether you draw dots or crosses, and it doesn't matter where you place them on the shell. If you've evenly spaced them out, that is fine, as long as you have the correct number of electrons on the correct shell, you will gain those marks. Okay, so here's a slightly higher level question, combining a little bit of both atomic and electron structure. So here we've got aluminium. It tells us that it's got 13 electrons, and to draw the structure, so we start in that inner shell, 2 in the first shell, I can place 8 in my second. That gives me a total of 10 so far, and I've got 13, so I'm just going to pop another 3 somewhere on that outer shell. 2 subatomic particles in the nucleus. So again, this is knowledge, knowing where we find those. So in the nucleus we have our protons and the neutrons. And why is there no overall electrical charge? So we've got no overall charge because the number of protons is equal to the number of electrons. Okay, so we've got the same number of positive and negative charges, and therefore they cancel each other out. Okay, here's an isotopes question. So this is a lower level isotopes question. Question tells you that there are 2 isotopes of hydrogen, hydrogen 1 and hydrogen 2. We've got a diagram of them as well to help support. Use the correct words from the box to complete the sentence. The positive particles. So again, you need that knowledge, but the information is there to try and prompt you. Positive particles are the protons. The particle with no charge it is neutral, is the neutrons. Okay, so again, even though this question is about isotopes, it's testing your knowledge of atomic structure first. Got to get those fundamentals locked in, because everything else builds on those fundamentals of that atomic structure. Then we've got 2 molecules of water, so we can see we've got hydrogen bonded to the oxygen, and it asks us to draw a ring around the correct answer. So it says that molecule A is something than molecule B. Is it heavier, lighter, or the same as? Well, molecule A is made up of the hydrogen that has a mass of 2. You can see there in the little diagram that we've got the number 2 up at the top, and so therefore these are going to be heavier, because the only difference in them is their mass. Explain your answer. So why are they heavier? So we can say that molecule A is made up of, and you can word this in a number of different ways. You might identify that it's made up of hydrogen 2. Bear with me, let me just move myself out of the way a moment. So it's made up of hydrogen 2, which has an extra neutron. Yeah, we've identified for 1 mark that it's made up of hydrogen 2, and for the second mark we're also backing ourselves up, saying that it's because it's got an extra neutron, and therefore that is making it heavier. And just to finish off then, we've got a higher level sort of question around isotopes again. So 2 isotopes of oxygen this time, oxygen 18 and oxygen 16. Describe the similarities and the differences between the isotopes. You should refer to the number of subatomic particles in each isotope. Okay, so here we want to talk about the similarities. Is that they both have 8 protons and 8 electrons. When you are answering questions about isotopes, the key thing is the protons, because remember the protons defines the element, and the difference in the neutrons to give the different mass. The electrons isn't as important, but if you put it in your answer, that is absolutely fine. So the difference is that, and we want to try and identify, we could say that 1 oxygen has, and if we look at the numbers up at the top, we've got 18 and 16. So that means that 1 oxygen, if we've got 18 minus the 8, so 1 has 10 neutrons and the other has got 8 neutrons. Okay guys. Right then guys, well I hope you found that session useful. If you do have any questions or queries, please do feel free to reach out and I'm happy to help support you. Okay, I'll see you next time.